over than 21 years in custom manufacturing system. I definitely know it lead us to understand the concept and also the practical exposure of Industrial 5.0. So we are really honored to have you here with us. We will learn more from you and implementation in our particular subjects and give us also the real exposure to our students for their growth in the field of industry. Thank you, sir.
Thank you so much, sir. I would feel really honored to introduce our guest. Mr. Rohit Srivastav, sir, brings with him over 21 years of industrial experience in custom manufacturing systems, smart production, manufacturing initiatives, PL Tech Electric Private Limited, focusing on scalable and adaptive systems under the Industry 5.0 models. He has been instrumental in integrating customer-driven design with flexible, human-inclusive manufacturing, a concept central to the future of personalized production. Sir, we are privileged to have you here. I now invite you to share your insights. Sir, now stage is yours. Please, sir.
मेरे को वीडियो चलाने के लिए मैं वीडियो दिखाता हूँ एक बार आपको। कंट्रोल दबा के इसका क्लिक कर दीजिए, ठीक है। इस पर आपका चालू हो जाएगा। इसमें जो ये वाला है ना, ये जो दिख रहा है बिल्डिंग वर्चुअल, इसमें आपको डायरेक्ट 3 पे आना है। 3 हाँ, यहाँ ये ठीक है, बट ये 3 पे आएगा ना तभी करना है आपको। मतलब यहाँ पे मेरे को स्पेसिफिक यहाँ से 3 पे 3 जो दिख रहा है
3 मिनट से करना है।
हाँ 3 मिनट से स्टार्ट करना है, ठीक है। बाकी हाँ, और एक लास्ट में ये दिखाना है, लास्ट में ये डला हुआ ना ये वाला जो वीडियो, ठीक है। इससे फास्ट किधर इधर
फॉरवर्ड पे अभी पीछे
Okay. Sorry for the delay. Good afternoon, all of you. So, that our subject is the personalized and custom manufacturing, mass customization in industry. That is belongs to industry, of course, industry 5.0. So, how the industry for 5.0 is started and what is the journey of that? So, I will take you through that. If you see that first our industry 4. What is the meaning of the industry 4.0? That is the revolution. Revolution means transformation. So this transformation milestone is this 1.0, 2.0, 3.0, 4.0, 5.0. So what is it that 1.0? 1.0 is known as when the human identified the uses of the steam and water power. So that is the first initiation of the 1.0, but during the time they identified that we are not productive so much in the industry 1.0, so there is a need comes to industry 2.0. If in industry 1.0 there is a product, one product is manufactured in the stationary kind of thing and manufacturing in the 6 days, so same thing that comes to the mass assembly line. So they have initiated the mass assembly line, and in the mass assembly line the same product is within 1 week reduced to 1 day. After that simultaneously work. So that is the introduction of the mass assembly line, that is known as the industry 2.0. In industry 2.0 there is a after scenario, every product market you can see that increasing the production competition. So that time needs comes to we have to more profitable and less wastage in our company. So that things comes to industry 4.0. There is a automation and that our custom manufacturing that is comes to. After that this mass customization and that you can say that using the cyber security, if we have using the automation, there's lots of dependency of the software, so we have to see that our information is not gone to the incorrect hands. So that's why that comes to industry 5.0. There is a need of the cyber security, mass customization. These are the things is come. So first I will take you that what is the business model of the one of the company. The business model of the company is that they sell the product and generate the revenue, and these revenue is sales is categorized in the two category. One is the expenses, other one is the profit. So if you are taking the profit, remove the profit, expenses is two categories is further divided, is a value added or non-value added. Value added that thing is value added process who contributed directly to the productivity, who increase the productivity of the industry. But non-value added things is those things who's not contributed the productivity and increase the they are generate the wastage in the terms of the time and in terms of the cost also. So some of the example I take you through that, like prototype failure, physical build part failure, ineffective process, logistic failure, cyber issues, vehicle driving failures, human skills, physical build ergonomic failure, process failure, machine breakdown, low quality and defect. These all over the defects, these all over the processes who is contributed to reduce the productivity of the company. how we will solve the problem through the industry 5.0. So I will explain in this further slides to you. So first I am taking that proto build failure. If one of the company has designed the product and they are going to in the virtual stage all over the design the product and going to the physical stage. So when they are going to the physical state, that's a lots of processes required. Casting is required, machining is required, you have to turning is required, lots of processes required at that time. So they have to go on through all over the processes for doing the prototype, build the prototype. If the prototype is not serve the purpose or serve the objective of that journey should be restarted, and that is required the time and cost also, definitely. So what is the prototyping issues? Is solution is 3D printing. So right now the people is using, we further is discuss more on the 3D printing. Same with physical build part failure and machine breakdown. Suppose that we are design the product and doing the manufacturing first time in this product. So we go to the assembly line and build the product. So what happened, that is the product is not a manufacturable. So but when you design the product and you have make the product, you have to give the tooling cost to the vendor. And if manufacturable product is not there, again design changes has happen, again tooling cost should be incurred. So that is the reverse cost that incurred in the traditional manufacturing. So what is the solution of that? That is the digital twin and virtual manufacturing. Third is the ineffective process. So right now we are not taking the much more data in the industry. What is the machine is doing that? If I am taking the assembly line example, what is the conveyor is running, how the conveyor data is giving that we have not captured in the traditional manufacturing. In the industry 5.0, due to that the major breakdown is coming, like 1 hour or 2 hour or 1 day breakdown is coming. That is the productive losses of the 1 day. That is the huge cost for us. So that is the solution is the big data and analytics. Logistic failure. Logistic, there's a backbone of the company where you have served the material from line to store to line. That is the lots of, in the traditional manufacturing there is the lots of dependency of the manually that parts is going that. But what happened, the manual is dependency is not an effective process. Sometimes a person is not come, person skills is not there. So that's safety chances is also. So there is a solution is come that autonomous robot, AMR, autonomous mobile robot. Then cyber related issue, if you are taking that so much data in your company, so what is the authenticity, where is the that who can check that and where is the data is filtered or not. So there is the solution is come that blockchain case. Vehicle driving failure. There are lots of control units in the vehicles today's scenario. So this control units is not malfunction. That's why that's solution is come that Internet of Things. Human skills failure. Sometimes what happen that when person is goes to the for attending the breakdowns and he prepare the solution, but he don't know that what is the part is fitted in there. He don't know what is the control panel is there, where is the wiring harness there. So there is the solution is comes that augmented reality. Then if you are manufacturing the product and that manufacturing you want to validate in the virtually, so that solution is comes to virtual reality. And same thing, the low quality also, defects you can prevent through virtual manufacturing. And the all over things systems is runs on the, that is the known as the PLM, MES and ERP. This is the softwares, that's a product lifecycle management software. MES is a manufacturing execution software and ERP enterprise resource planning software. The three software is a one umbrella is working on the any automotive industries. So why the need comes to for 3D printing? the 3D printing needs comes to key traditional, like I said, that key prototyping, CNC machine, injection molding, that is a time consuming and maybe expensive also sometimes. So that prototype cost is very high. High tooling setup, whatever the vendor, he asks that we manufacture this product without tooling, he give the costing is a very high for the tooling. After that, customer not able to customize the product. He wants to customize the product apart from the vendor standard processes. So he don't do that. There is a limitation of that. Lightweighting, whatever he is dependent on the vendors, whatever the vendors is available, the processes, whatever is a vendor available, the machines, he will generate based on that. He take a call because his dependency on the vendor. Custom jigs and fixtures that he can't make, he should make to himself. And material wastage also for that, because every vendor should be asked the material wastage cost, here your cost. So there is one example of that. You can see that this vehicle all over the 3D printing is required is a 52 hours. If we go for this whole vehicle's prototyping in the traditional method, that is required approx 6 months. One of the case study I will share with you. Harita is a leading automotive seating manufacturing company. They relied on the FRP or thermostat prototyping. So whatever the mold they have prepared, they have required the 7 to 8 days, and the cost should be 5,600. The solution comes to, they have taken the 3D printer, industrial 3D printer, capable to producing the full size prototype in one go. You can see that in previous challenge, they are making the part components and assemble the components with some of the gluing. So there is a limitation of the technically vibration can't sustain the glue. So that's why they did not check the functional testing also this. But in the 3D printer, they assemble the whole prototype in the one shot go. There is no connection and assembly is required for that. So they will check that functional testing also there. So you can see that the results is that key time required traditional method 8 days, 3D printing 2 days, saving is the 75%. Cost 5,600 and 3D printing is the 1,800. So what is the benefit? Impact is over week to under 2 days, cost slashed, enable full scale functional assembly prototype, faster iteration and positive feedback to engineering team. So where we can learn? Additive manufacturing is the FDM, fused deposition method, modeling. So this is the one of the thermoplastic where you can extrude it and layer by layer you can create it. Second is SLA, stereolithography. That is the system for UV based, where do you extruded the layer and the resins in the UV content. Ultrasound. And SLS is the laser, where you extruded through laser. Materials, if you say that this is a polyacetic acid, acronym ABS, that is known as the asbestos sheets also, and PETG, polyethylene tetrafine glycol and resin. So these are the materials you can learn about that, where we can see the 3D printing and how due to this process and due to this material you can further explore the knowledge about the 3D printing. Types of printer is the Prusa, Creality. These are some of the printers name. The another topic is come that digital twin. Digital twin is related to that synchronization between the virtual and physical worlds. So whatever the virtual worlds we have simulated, the same thing should be happen in the physical worlds also. That is the known as the digital twin. So what is the benefit is that why this need is come that the need is come that thousands of the mechanical electrical parts is there and software components. So that synchronization should be required. Then integration, that also I have already told you. Second thing, whatever the things materials assembly that is required, some of the prototyping and testing costs. Then another is the downtime layout issues. Bottlenecks of the factory means you bottleneck one materials to another, one place to another. You have the non-valued movement is there. So that is the delay. And limited predictive analysis. We don't have the predictive. We have the only that the maintenance. Whenever the breakdown is come, that we going to the attend the breakdown there. So one of the video I will share with you. So that video actually that is the giving you the perfect example ke how that digital twin is work. This is the video for the one of the robot programming in the industrial robot. Industrial robot is we have done other lots of teaching, and that's the physical teaching. This is known as the offline programming. You can see that this the teaching is required whatever the previously traditional manufacturing, the Kuka, Yafano, these are the robot manufacturer. They doing the teaching and lots of time is required to this teaching. But due to this software is come to, that software name is the Delmia, and Delmia offline programming, you can virtually teach the product, and that products, if you connected this product to the physical product, that physical product behave like whatever you are simulate in the virtual level. And there is no separate programming should be incurred in that whenever the teaching is happen, that programming should automatically grasp by the robot and memorize it.
With this level of precision and flexibility, even complex tasks become manageable, helping you reach
The 3.0 offline programming.
virtual commissioning.
Yeah.
So you can reduce your commissioning time.
Yes.
Offline program your robots so the existing workflow is not interrupted. On the main screen, you see a virtual simulation of a robot arm performing pick-and-place operations. In the lower left corner, you'll notice the real-world robot mirroring those.
This is the 6-axis robot,
This single
and every axis has required lots of programming and teaching in the previously without this software.
testing and
If you can say that this is a required approximate 1 week or 2 weeks to teach the product, and this is the after the software is come, that is required a hours job, only hours job.
These same instructions transfer seamlessly to the actual robot. This approach minimizes production downtime, improves safety, and ensures smooth operation from the start. Delmia Robotics makes it easy to adapt existing programs, accommodate design changes and scale automation, all without halting your production line. With this level of precision and flexibility, even complex tasks become manageable, helping you reach higher efficiency and shorter turnaround times. Virtual commissioning.
So what is the benefit is right now you can see that there's BMW, Ford and Nissan, they are frequently use the digital twin, and they have their benefit is that 25 to 30% faster planning, that front load the overall planning in the physical to virtual level, 25% design cycle and 50% cost, and lead time of the launching the product they have also reduced through that. And Nissan has heavily used for digital twin is the prototyping cost, and they have reduced the 40% of his prototyping cost. So that is the some of the software name where you can use that for learn that for digital twin. There is a different purpose. There is the Delmia for the, you can say that solution for the virtual manufacturing, identified the bottleneck for the manufacturing environment. Azure is the that software is the cloud-based solution where your data is the cloud-based, where you can connect the digital twin. MATLAB is the, you can see that is the component base where you can simulate the product and check the feasibility on component in the design level. Simulink, same performance the Simulink also. So these are the some ANSYS. ANSYS is known as the behavioral of the environmental condition of the vehicle, that we use the ANSYS also. and Cosmol physical solution. So these are the Arduino, Raspberry Pi. This is the electronic related software, whether you hardware check the hardware and software in the with sync working or not. So these are some of the software name. Big data analytics, there is a lots of sensors and VCUs is connected in the vehicle, and then sensors data and malfunctioning that should be prevented to that analytics. And this analytics processes a very high speed, so that's why decision making should be very easy. So reduce the unexpected breakdown, whatever that things, say cost saving and customer satisfaction. So there is one study that Tesla conduct the massive data from its fleets. If you see that the Tesla is autonomous vehicle that already in the roads, some of the countries, so generate the how much data, the every data they have captured, the seconds of the data of the vehicles they capture it, and after this collects the data on, after that using the AI they reprocess the data, churn out the data, and after that they can take the decision based on the algorithm they will put on the this big data analysis. So that is the benefit got: driving safety and decision making, reduce accident, and enhance the vehicle performance. So big data analytics not only the autonomous robot, that is every area of the vehicle side, vehicle manufacturing, that is the working on, like supply chain, connected cars, automobile financing, predictive analysis, design and production. Supply chain is what is the best route is taking the vehicle through vendor to inside the factory premises, inside the material movement of the factory. Connected cars, whatever the communication, the car is coming, that one car is coming, another car, so what is the distance is there, how much distance is safety or safe or not safe, that is the automobile financing. So what customized solution of the financing of the customer. Predictive analysis in the manufacturing environment, suppose that you have required the know about that that should be failure in the sometimes, that data should be predictive analysis through the big data analytics. And of course the design and production, design prototyping. So these are some of the tools for data analytics and business intelligence. So in the logistic movement, there is I already showed that inefficiency in material handling, transport, time consuming, inconsistent, and not safe sometimes, and very much depends on the human manpower, labor intensive. So that inventory and production line difference, if you say that you require some of the lines is going on the some takt time 6 seconds, like Maruti is working for 48 seconds, and some of the battery manufacturer, lithium ion battery manufacturer, they works on 5 second or 3 second takt time. Every one cell should be coming after 3 seconds. So that is the requirement that in 3 seconds, in 2 seconds that material should be online. So that is the one of the challenge. Then high operational cost, forklift, manual cards, that of course required the human. So that is the double cost for the human also and the machinery also. And sometimes the human so possible is the human error also. So workplace safety is a very much important for that. So there is the solution comes to AMR, autonomous mobile robots. So these robots is previously there is a limited technology based in that they are the magnetic chip technology, whereas the magnetic chip should be pasted on the floor, and this autonomous robot is trace the magnetic chip and goes to the path. But right now that is lots of technology is coming, and in the automobile sector there's a lidar based technology is quite popular, that is the light detection, due to light detection. So that technology works that. So due to that you don't need to define the path of that robots. The path itself is the programming has capable to doing that, and after that someone is coming to the in the path of the autonomous robot, that programming should be there key that will stop the product whenever the whenever the stuck up is there, so that problem is goes. After that this start. So this is the AGV benefit. What is the material? Improved material handling. So AGV transport raw material parts and tools precisely and continuously. Reduce dying time. Whatever the downtime is comes through forklift and manual carts, we reduce through that. Lower labor cost. So don't need any human intervention, so cost is not there. Increase the productivity. Whatever the sometimes this autonomous robot is once 2 meter per second. That is the highest speed. Smart integration, you can use that AI and tools, so dynamic path planning and itself is taking the decision of the path, that smart integration, and human error is not there, so chances of the error are very nil. And safety, definitely enhance safety because there is no human is there, so there is a safe environment. So AGV, these are the component are that LiDAR sensor, light detection ranging, microcontroller processor, power supply, mounting platform, connectivity, and softwares. So these are the some of the makes is giving there. So one of the technology is the blockchain technology. So blockchain is a lack of trust among parties. You can decentralize, matlab, it is not only that cryptocurrency they are using it. This is the above than the cryptocurrency also. So these are mainly for the how you maintain the data integrity and how you share the information communication with filtered environment. So these are the area where the blockchain is working: insurance, car sharing, payment. So insurance sector, definitely whatever the needs of their, who is the customer portfolio, they identified that. What is the car sharing platform, where is the big data is required, where the blockchain is coming. IoT, so Internet of Things. So Internet of Things is the challenges is the why the need is coming, that unplanned maintenance and breakdown. Whenever the industry manufacturing environment there is an unplanned maintenance, so we don't have the data is that where this sensor is put it down there, so what is the motor is, what is the life is there, so that is data should not be available. So someone should go to the file and check that where is the motor purchased that and what is the make of the motor or what is the specification of the motor. We use that IoT, through that we take this data all over the cloud platform and identify that all information should be access to all pupils. Inefficient manufacturing factories, like today is the, like I said that there is not a communication. So if you see that in the every vehicle has some chassis number, and they starting this chassis number, this all over the information is come to the VCU, through VCU connected the information all over the vehicles, what is the brake status, what is the oil status, that all over the information should be there. So that data previously not available. So that time what happened, that same thing is happening in the manufacturing line also. When the vehicle number we will put it down, that after that we fill the brake oil, we fill the coolants, we fill the steering oil, and after that we tight the tire nut tightening perform on that vehicle, U-bolt perform on the vehicle, axle and leaf spring assembly. So these are the critical joints, so that data should not available. Where is that? So whenever the failures is happen in the this field, so there is no access information or root cause information why this happen, and there is no solution is there. So that is required lots of time to perform it. So through IoT that should be going to the cloud, so manufacturing person should access the data, and field person and after service person they will access the data. Second, road accident and safety issues. So vehicle to vehicle communication and automatic ADAS system, that is the prevent the collision, and communicate each other and giving the indication signal to both of the vehicles. So that is the one of the area is coming that where IoT is work. Poor traffic and route planning. So right now you have seen that Google Map, that is a whenever giving you that these are the traffic congestion area, so that Google Map indicated you this is a pure traffic. Fuel inefficiency, that right now is the in the vehicle the fuel efficiency also, and sometimes the tire pressure monitoring is also coming that through that. Lack of real time vehicle data. We don't know that a fleet operator, if that one of the feature is coming, the telematics, where we can know that where is the operator is there and how the operator in which time that operator should be reach his location. Security risk. So GPS tracking where and geofencing. This is one of the feature is geofencing, that using the vehicle you have integrated your geographical position in your vehicle. After that geographical position that the vehicle took to the outside this geographical position, that vehicle not start. So that is the geofencing should be started. And supply chain transparency, where the delivery real time monitoring, how much time we will reach there, that is the correct data, whatever the capacity of our vehicle that we will reach or not, and after that when we return that, can't we take to another supplier to another material. So the milk van technology. So these are the hardware should be integrated in the vehicle, just like GPS in navigation, lidar, video cameras, radar, position sensors, central computer or ultrasonic sensors. So if you want to start, so these are the learnings where you have to understand what is the sensors is required, actuators what understanding is required, and how the wiring is required, which core wire you have to use. Then Arduino, for start the small case study and project through Arduino, and some of the basic knowledge of the networking also. There is a who is there. So start karna. कंट्रोल प्लस, हाँ हाँ कंट्रोल प्लस ठीक. Augmented reality is known as that physical world we are taking that. So through physical world interaction through mobile softwares and this, we identified the this information. Like basically this video you can see that the person is through this virtual augmented reality, he identified what is the process and what is the part should be picked in the sequence wise, and how the assemble is. Without having the skills, he can do it, normal person can do it. You can see that this is the part he will prepare that, so that giving the information, and after that there is a process is coming that what is the remove, and that all over the process should be recorded. So that is the interaction with physical world by the software, and that software giving the information about your physical world through. So that is the things is that there is no chances to incorrect fitment of the assembly. Right process is we can fit, and right process we are adopted. Third thing is that what is the overall accuracy that should be maintained. So there is a no need of the manpower. He is put his mind what part should be required and what part should be fitted. So every light should be indicated, process should be written lower side, that should be fitted there, and this this length and this size. So if he wants to do the mistake, he don't. Okay.
आया क्या एक बताओ स्कूल में तो कॉलेज में क्या क्या होता है
This is the virtual reality. So virtual reality is the difference between where augmented reality you interacted that and they give the information of the physical world. Virtual reality you itself in the virtual world and you control the virtual world. Slow the sound. You can see that you will make the equipment that some of the virtual apparatus is coming that, and this is the software you should build in the computer. Through this virtual apparatus you can interact this virtual environment. It goes to the virtual environment and perform the operation. Any of the operation you can perform, any of the design simulation you can check that. Through that you can check that what is the ergonomic height should be the door, what is the cabin ergonomic height, what is the process should be adopted. So that is the one of the video is that what is the process should be adopted, and you feel that process without physically fitted the weak part on it. So if you are not taking the correct parts, that indicate you that you are not taking the correct part, correct tooling is there. So that indicate you here also, because you have to put the logic on that. Okay. So there is a last video, एक video, this one. This is the one of the example of my previous factory where we have adopted the industry 4.0 practices, and so there's lots of things you can start that. So this all over the factory we have created in the 3D environment. In the every parts, every trolley, every jig, every fixtures, we goes to the on production shop floor. We measure the things and convert in the 3D environment and put it on the 2D layout. So these are the trolleys. You can see that these are the material handling equipments. Whatever the AGV is put it there. Floor X and converting the chassis, toppling the chassis. So these all over the we have converted in the 3D environment for the virtual build the product, and virtually we all the product built on this before the launching of the vehicle and identified the non-conformities before going to the physical worlds. So that is the one of the BOM creation. There is a just a minute, stop there. There is a one major problem is coming to the every OEM manufacturing like Tata Motors, yeah, you can say that Eicher Motors. There is a E-BOM and M-BOM differences. E-BOM is known as the engine BOM, that is the pertain to the design environment. M-BOM is pertaining to the manufacturing BOM. So what happened that why this differences is coming that every time, because E-BOM designer is changing the design every time. So whenever they change the design, they put the changes in the E-bomb, but that is not communicated to the M-bomb. So that is the difference is coming, that because material has using the old parts, manufacturing is using the old parts, so there is a difference between come that, and that difference is known that whenever the physical piloting is happen, oh, that part is not fitted. Why this part is not fitted? Because this is part is old part, and that part is should change by the design. So that's why this the things is coming that. So one of the solution is that in the software we automatically generate the M-bomb. There is a no manual involvement. Previously that is the manually involvement, manually created the manufacturing bomb by the some of the engineers, but through the software we automatically generate the M-bomb through E-bomb. So these are the process for the how we generate the M-bomb. The E-bomb is you can say that is the overall parts is there, but we have required only bought out parts, so that is known as the M-bomb parts is there. So early detection, whatever the E-bomb or M-bomb issues that we can resolve here. You can little bit phantom drawing that we have created the all over the whatever the 3D drawings, but vendor don't have the 3Ds, so he required the 2D drawings. So what we have done it, we have a 3D drawing, automatically that software is converted into 2D and goes to the vendor. You can see that this is a 3D of the chassis, that automatically this chassis read the all over the data. We have put it down, the software is the behind that. This all over the read the data of the 3D environment and convert it into 2D environment in the 3 views, top view, front view or side view. Like that, this is the process. What is the sequence of the process we have to integrate it? This is the generate process plan of the every vehicle new launching process. So we can adjust the every process, whatever the free process is there, we can adjust to up and down side based on the line balancing requirement. There is a one case study I have shown to you. What is the benefit of this virtual manufacturing? This is the one of the things that we put the tie rod, that the new tie rod is coming that, and we put the existing axle. So how we identified that case, this fixture should be not capable to handle this tie rod. So this is the one of the case study I will show you, please. So you can see that this we have put it on the leaf spring on the axle, and we put U-bolt. This U-bolt we have tightening. And this person goes to the lift the tie rod and fitted this tie rod in the axle. And this tie rod is foul with fixture. So here we identified that if we manufacture this tie rod new, we build this tie rod, so we have to modify this fixture. So that before that physically come that we identified previously, and we take care that, and we created this fixture, modified the fixture accordingly, whatever the clash analysis results has come that. So based on that way convert that, and without physically come to the tie rod is a manufacturing environment, we have already prepared for that tie rod manufacturing. This is the mock-up. We have required the build the new vehicles, so we mock that how the product build should be happen. So based on the process, we doing the product build up in our system, means 1 hour, 2 hours, 3 hours, we build the whole product for different scenario. And after that we check the manufacturing environments. Like you can see that this is the axle, that chassis we have put it on the first axle. This is the U-shape layout, and how the cabin is fitted there, what cargo is fitted, and how the vehicle is moved there, and roll out the vehicle in the assembly line. So that scenario we can easily simulate through this software, through virtual manufacturing. So thank you, sir. This is my presentation that ends here. So I hope I have given you try to communicate you that should be touch you definitely. Any questions?
Dalmia software design all these things.
Design not a Delmia is a Delmia. What is the full form of the Delmia? Digital Enterprise Lean Manufacturing Interactive Application. So that is the work on the lean manufacturing. So in Delmia mainly you can work on the whatever the manufacturing inefficiency you can simulate in the virtually and don't go to the in the physical level. So that software is helps that in our previous company we have the save approximate 10 crore rupees through this tooling cost of this Delmia software.
This is a free.
No, it's not a free software. This license cost approximate 40 lakhs rupees and yearly renewal cost is 12 lakh rupees. That's
You told that vendor required the 2D diagram to build the digital twin in 3D. How come this 2D convert in the 3D?
This is same Delmia. We have some of the programming is required in there. So Visual Basic programming is there. So 2 to 3 program we have put it down there. That's condition we have put it down there on the visual programming and put it down the whenever we do the virtual manufacturing that program we put it on the this programming. So that program needs that and converts the 3D data into 2D environment in the front view.
वेंडर को डायरेक्टली वो 3D में नहीं रीड कर सकते हैं.
कई वेंडर होते हैं जिनके पास 3D की कैपेबिलिटी नहीं होती है तो इसके लिए वो 2D चाहिए रहती है उनको.
Any questions regarding this session? The student sitting behind. Thank you so much, sir, for the excellent session on mass communication and the evolving landscape of personalized production. Your industry case studies along with implementation frameworks have given us a clear roadmap to apply these principles in our classrooms, research and consulting practices. May I now request Professor Arun Singh sir from the Department of Computer Science to present a token of appreciation to our guest speaker.
Thank you. Thank you.
Now we can wait for VC sir so that we can complete the session.